With the project supply chain delivering materials to site, the focus in Chapter 7 shifts to how those materials are received, controlled, and issued to support construction execution without disruption. Once materials arrive on site, the warehouse becomes the control point that determines whether construction progresses predictably or is disrupted by avoidable delays. In capital projects, the construction warehouse is an operational hub responsible for converting delivered materials into installation-ready assets. Its effectiveness directly influences craft productivity, field coordination, cost control, and schedule reliability. As such, the warehouse must balance two critical objectives: maintaining control while enabling flow. It needs to preserve material integrity, traceability, and accountability, while also supporting timely distribution to work fronts with minimal wait time or rehandling. When warehouse operations are aligned with construction sequencing and execution plans, the warehouse becomes an active enabler of installation readiness, ensuring crews have what they need when they need it to execute work safely and efficiently. As projects adopt more integrated materials management practices and structured workface planning models, warehouse operations emerge as a pivotal link in the connected project supply chain. Digital receiving, RFID and barcode tracking, mobile warehouse tools, and kitting workflows shift the organization away from reactive material chasing toward intentional staging and controlled issuance. In this model, the warehouse does not simply hold materials, it verifies, documents, tracks, and positions them to support installation at the right point in the build sequence. The objective of construction warehouse management is therefore simple, but strategic, to ensure materials transition smoothly from delivery to installation with full visibility, minimal waste, and no surprises. When executed effectively, warehouse operations accelerate construction progress, improve predictability, and protect both cost and schedule, making the warehouse a foundational contributor to overall project performance. Warehouse and laydown strategy. In capital projects, warehouse and laydown areas are strategic assets that shape construction flow and execution efficiency. Their purpose is not storage for its own sake, but to support material readiness aligned to construction sequencing. A well-designed warehouse strategy integrates physical layout, zoning, handling practices, and digital visibility with how work will be executed in the field. Effective warehouse planning begins early in the project lifecycle. Decisions regarding indoor versus outdoor storage, proximity to work areas, environmental protection requirements, and access routing must be made in the context of construction phasing and work packaging. When warehouse and laydown planning are embedded within the construction execution model, rather than treated as a downstream logistics task, material flow becomes more predictable and field disruptions are reduced. Strategic grouping and positioning of materials based on anticipated installation needs minimizes unnecessary movement, reduces rehandling, and shortens retrieval time. This improves coordination between warehouse teams, construction supervision, and work planners, creating an environment where materials move purposefully through the site rather than accumulating reactively. Key questions to ask. Is the warehouse layout designed around construction sequencing rather than storage convenience? Are materials grouped and staged based on how and when they will be installed? Do warehouse planning decisions actively support installation readiness and field? Productivity, receiving, and verification. Receiving is the first point of control at the construction site where the digital supply chain becomes physical. At this stage, materials must be validated against purchase orders, specifications, and documentation requirements to ensure they are complete, compliant, and suitable for installation. A disciplined receiving process prevents downstream confusion and eliminates issues that become more costly to resolve once materials are staged or issued. Modern receiving relies on digital verification, not paper-based checks. Barcode or RFID scanning establishes a real-time link between the physical material, its documentation, and its assigned storage location. Capturing inspection records, certificates, and release documentation at receipt ensures that materials do not later stall installation due to missing or incomplete records. Over, shortened, damaged, and non-conformance management are critical elements of the receiving process. Incorrect quantities or damaged material needs immediate resolution with the supplier to ensure future workface planning is not impacted. Materials that do not meet specifications must be clearly identified, isolated, and tracked until resolution. Preventing non-compliant materials from entering general circulation protects quality outcomes and avoids costly rework, schedule delays, and field disruption. Key questions to ask. Are materials digitally verified at receipt to establish traceability and documentation readiness? Are non-conforming materials clearly isolated and managed through defined resolution workflows? Does the receiving process update system records in real time to support planning and visibility? Material identification and tagging. Clear and consistent material identification underpins effective warehouse control and efficient material flow. Tagging materials with barcodes or RFID identifiers connect each item to its digital record, ensuring that status, documentation, and location information remains accurate throughout the warehouse lifecycle. Digital location assignments are equally important. Materials must be associated not just with a warehouse or yard, but with a specific bin, rack, row, or zone. When location data is precise and accessible, warehouse operators and field teams can quickly locate materials, reduce search time, and eliminate uncertainty during staging and issuance. Strong identification practices improve coordination, reduce handling errors, and increase confidence that the correct materials are delivered to the correct work fronts. This level of traceability is essential for maintaining installation readiness at scale. Key questions to ask. Are all materials consistently tagged upon receipt? Can teams quickly identify the exact physical location of required materials? Is material identification fully integrated with the digital materials management system? Storage protection and handling controls. Storage protection and handling controls play a direct role in protecting both cost and schedule performance. Materials that are damaged, degraded, or misplaced introduce rework, replacement costs, and installation delays that ripple across the project. Effective storage is therefore not passive, but it is a strategic safeguard for execution reliability. Protection requirements vary by material type, environmental exposure, and sensitivity. Applying these controls consistently prevents corrosion, contamination, deformation, or premature deterioration that can render materials unusable or require costly remediation. Preservation failures often surface late when materials are needed for installation, making their impact both expensive and disruptive. Handling practices must also support efficient flow. Poor handling increases damage risk, consumes labor, and introduces delays through repeated movement. When storage layouts are designed around anticipated usage and issuance sequence, rehandling is minimized, retrieval is faster, and installation readiness is preserved. Together, these controls reduce waste, protect quality, and maintain the schedule integrity. Key questions to ask. Are storage and protection requirements clearly defined and enforced based on material risk? Does the storage layout minimize handling and support efficient retrieval? Are preservation and inspection activities integrated into routine warehouse operations? Work package staging. Work package staging, often referred to as kitting, represents the transition from material control to productivity enablement. By assembling materials required for specific installation scopes, warehouse teams ensure that crews arrive at the workfront with everything needed to execute work without interruption. This reduces wait time, eliminates searching, and stabilizes crew productivity. Effective kitting depends on alignment with short-term construction look-ahead planning. Materials must be grouped, verified, and staged in advance of scheduled work, with both quantity and documentation completeness confirmed. When this alignment exists, construction supervision can commit to execution with confidence, knowing that material constraints have been resolved upstream. Kitting also improves safety and quality outcomes by reducing congestion and ad hoc handling at the workface. It reinforces a disciplined execution model where work is released only when it is truly ready to proceed. Key questions to ask. Are materials kitted and staged in alignment with near-term construction plans? Do kitting processes ensure completeness before materials are released? Are staging areas designed to support predictable, uninterrupted installation, issuance, and workface delivery? Material issuance is the moment where warehouse operations directly enable field execution. Mature projects treat issuance as both a controlled pull process and a planned release aligned to construction sequencing. This ensures materials are delivered intentionally rather than reactively, and that issuance supports rather than disrupts workface productivity. Digital issuance tracking preserves accuracy and traceability while providing real-time visibility into material movement. Point-of-use delivery reduces travel time, search effort, and handling at the workface, allowing crews to remain focused on productive installation activities. Well-executed issuance reinforces trust between warehouse teams and field supervision, enabling smoother coordination and fewer last-minute disruptions. Key questions to ask: is material issuance aligned to construction plans rather than ad hoc requests? Are issuance transactions digitally recorded to maintain system accuracy? Does delivery minimize handling and crew downtime? Inventory, accuracy, and reconciliation. Inventory accuracy is fundamental to planning confidence and schedule reliability. When system records reflect physical reality, planners and supervisors can release work, knowing materials are available and ready for use. Inaccurate inventory undermines trust, drives contingency behavior, and leads to inefficiency. The ultimate objective in a capital project is to consume materials as planned and close out with minimal remaining inventory. In practice, however, residual materials often remain due to design changes, scope adjustments, over-procurement, or contingency purchasing. Accurate inventory records are therefore essential not only for day-to-day execution, but also for identifying surplus early enough to influence decisions such as reallocating materials to upcoming work, canceling pending deliveries, or adjusting procurement strategies. Project warehouse management must also address inventory disposition planning, not just reconciliation. Remaining materials may need to be transferred to operations, returned to vendors, scrapped, or redeployed to other projects. These outcomes require clear ownership, defined processes, and designated physical space. When disposition planning is left until late in the project, warehouses become congested, accountability becomes unclear, and the transition to operations is disrupted. Leading organizations define inventory transition strategies, early identifying what materials are expected to roll into operations, which may be returnable under contract terms, and which require special handling or disposal. This early clarity ensures that the right stakeholders are engaged, appropriate storage and inspection areas are allocated, and systems are prepared to support ownership transfer. In this way, inventory accuracy and reconciliation extend beyond warehouse control to support orderly project closeout, smoother handover to operations, and reduced financial leakage. Key questions to ask: does the inventory system accurately reflect physical availability? Are reconciliation activities integrated into daily operations? Does the project materials management plan incorporate inventory transition strategies to operations, digital tools, and field enablement? Digital tools are foundational to transforming construction warehouse operations from localized manual activities into an integrated extension of the project supply chain. A robust materials management solution provides the single source of truth that connects receiving, storage, staging, issuance, and inventory reconciliation across both the job site and the home office. When warehouse systems are fully integrated with procurement, expediting, cost control, and construction planning platforms, material status becomes transparent, reliable, and actionable at every level of the organization. In the field, mobile-enabled warehouse tools support real-time execution. Barcode and RFID scanning, digital location management, and mobile transaction processing eliminate manual data entry and reduce errors that erode confidence in inventory records. Warehouse personnel can confirm receipt, movement, and issuance immediately, while construction supervision gains instant visibility into material availability without relying on phone calls, spreadsheets, or physical searches. This responsiveness reduces delays at the workface and improves coordination between warehouse teams and construction operations. Equally important is integration with enterprise systems in the home office. When warehouse data flows seamlessly into materials management, ERP, project controls, and reporting platforms, leadership gains a clear current view of material readiness, inventory exposure, and risk. This integration enables proactive decision-making around resequencing, expediting, preservation planning, and inventory optimization. Over time, analytics derived from these systems support continuous improvement by identifying bottlenecks, recurring discrepancies, and opportunities to reduce handling, storage duration, and excess inventory. When digital tools are aligned to warehouse processes and embedded into daily workflows, technology becomes an enabler of control rather than an administrative burden. The result is a warehouse operation that is predictable, auditable, and responsive, capable of supporting project execution with confidence and scale. Key questions to ask: Is there a single materials management system that connects warehouse operations with procurement, project controls, and construction teams? Do field and warehouse teams rely on real-time digital tools rather than manual tracking or informal communication? Does current warehouse infrastructure, mobile internet, Wi-Fi boosters, and data security match the data integration requirements to track as efficiently as possible? KPIS and material readiness metrics. Performance measurements in construction, warehouse management must extend beyond transactional efficiency to focus on material readiness and execution reliability. Traditional metrics such as receipts processed or inventory value on hand provide limited insight into whether the warehouse is truly supporting construction progress. Instead, KPIS should answer a more critical question. Are materials available, verified, and positioned to support planned installation without delay? The most effective metrics measure readiness in context. This includes visibility into whether materials are physically available, properly stored, documented, and accessible when required. Readiness-focused KPIS allow project teams to identify risks early, adjust staging or sequencing plans, and avoid last-minute disruptions that lead to crew downtime or work resequencing. When readiness metrics are aligned with construction priorities, warehouse performance becomes directly tied to schedule confidence rather than isolated operational output. Supporting efficiency metrics remains important, but they serve as enablers rather than end goals. Measurements such as inventory accuracy, issuance cycle time, and retrieval efficiency provide insight into the health of warehouse processes and controls. When reviewed alongside readiness indicators, these metrics highlight where improvements in layout, tagging, staffing, or digital tools can strengthen reliability and reduce waste. This balanced approach ensures the warehouse operates with both discipline and purpose. By establishing KPIS that reflect material readiness and operational effectiveness, organizations create transparency and accountability across warehouse operations. Leadership gains confidence that material-related risks are visible and manageable, and warehouse teams understand how their performance contributes directly to project success. Key questions to ask: do warehouse KPIS clearly indicate whether materials are ready to support planned construction activities? Can readiness and inventory accuracy be assessed in real time, not through after-the-fact reporting? Are efficiency metrics used to drive continuous improvement rather than simply track activity? Thinking about the future of construction warehouse management is defined by increased integration, visibility, and predictive control. As projects grow in scale and complexity, warehouses must evolve from static storage facilities into dynamic operational hubs that anticipate demand and support execution with precision. Emerging technologies such as advanced RFID location tracking, automated inventory reconciliation, and digital warehouse twins are enabling real-time awareness of material location, condition, and availability across large and distributed sites. In this future state, warehouse operations are no longer reactive to delivery or issuance requests. Instead, they operate with foresight using integrated data from procurement, logistics, and construction schedules to anticipate material movement, staging requirements, and preservation needs. This predictive capability reduces excess handling, minimizes congestion in laydown areas, and shortens the time materials spend idle on site. As a result, inventory carrying costs decrease while material availability improves. Ultimately, the future construction warehouse is not defined by technology alone, but by how well digital capabilities are aligned to disciplined processes and execution priorities. Organizations that invest in integrated systems, strong data foundations, and clear operational models will position their warehouse operations as a strategic advantage, improving cost control, protecting schedules, and strengthening overall project predictability.